What's up, everybody? I'm Farhad from Ethnotek Academy. Have you ever been using an application when it suddenly crashes on you, it freezes up, or it just completely restarts? What happened?
Damn it, why would it work?
Chances are you ran into an exception the developers didn't handle. Today, we're going to talk about what exceptions are and how to use Java to handle them in a way that prevents your application from crashing. Let's get to it. Before we write any code, let's talk about what an exception is. In a software application, an exception is an event that disrupts the normal flow of a program's execution. It's an unexpected event. For example, let's create an array of integers. I'm going to add a print line that will attempt to print the 10th index value in nums, which of course doesn't exist. So what happens if we run this code? We get this exception that says array index out of bounds exception. Index 10 out of bounds for length 3. What's important about this exception being thrown is that when an exception is thrown, it actually causes your application to crash. For example, if I write anything after that line, if I try to print out hello, this will never run because the application is going to crash at this point. Let's rerun it so we can see that take place. So we get this array index out of bounds exception again, and notice that hello never gets printed. This is where exception handling comes in. Programming languages allow us to write code that prevents our application from crashing in the case of an exception. Most programming languages will handle this with a try-catch block. Here's what this looks like. We start with the keyword try, a block of code, and then the keyword catch, followed by a set of opening parentheses, and another set of square braces, curly braces. The way this works is whatever code that we write in the try block is going to be attempted. And if this code fails with an exception, the catch block of code can be used to handle that exception in a way that prevents our application from crashing. Let's test this out by using the same scenario and trying to print the 10th index value in our try block. So here, let's copy and paste this. And in the catch, here we'll specify what exception we're trying to handle. So we'll write out array index out of bounds exception. This is the class, and then we'll give it a variable, err, which is short for error. And so we'll say, if this statement throws this exception, we'll handle it by printing this out. So when our try block of code runs, if this throws an array index out of bounds exception, we're going to catch that here and print out array index is out of bounds, and then we'll also print out whatever error is received. Let's run this and see how it works. First, let's comment out our previous code. Cool. So we get this feedback saying array index is out of bounds, and then this entire line is the ERR variable. This is the parameter that we added to the catch block of code. Java.lang.arrayIndex out of bounds exception, index 10 out of bounds for length 3. You can think of the try catch block as the airbags in a car. You hope you'll never need them, but if you do, if something goes wrong, those airbags are there. Let's also add back our print line for the hello string, just so we can see that this will be run now. So our application is no longer crashing because we have a try catch block of code. So we should this time see this hello get printed. And there it is. Okay, but what happens if the try actually works? If we pass something in the try, so let's print out the 1th value in the array. There is a 1th value, right? 0 and then 1. So this 2 will get printed. So this shouldn't throw an exception. If the try block of code doesn't throw an exception, the catch block will never run. So in this scenario, we should see the 1th value be printed, and then the catch block will be skipped, and then the rest of our application will proceed to run as expected. There, so now we just get a print line for 2 and then hello. Okay, so this is fine and all, but we of course would not use a try catch usually on an application like this, where we ourselves are specifying what value in an array to print, right? So when would you use a try catch block? A couple of common scenarios are if you're getting input from a user, right? So if you wanted a user to input an index value and have that value be printed from an array, that's a time you would use a try catch because you cannot control what value the user is going to put in, right? They might put in 100 for an array that only has 3 items. Another scenario is if you're trying to write an application that contacts a server or a database, because again, you cannot control whether that server has an open connection or if your application has permissions to contact that server or database. Here's another real world scenario for using a try catch block. We'll have a text file sitting in somewhere in this project, and we'll have code that just reads each line from that file and prints it to the console. Let's start writing that code without using a try catch and just see what happens. So we'll create a string, file equals essay.txt. And we'll actually create this .txt file. So I'm going to right click on my project, exception handling, go to new, file, and we'll call this essay.txt. And ChatGPT was nice enough to create this essay for me. It's just 7 lines, roughly 100 words, on how awesome Java is. Now, in Java, we can use something called a buffered reader, which is used to read some kind of text-based input stream. And we'll we'll create a variable called br equals new buffered reader. And then in these parentheses, we want to pass what kind of text, what is the input that the buffered reader is going to get. And here we'll specify file reader. File reader is exactly what it sounds like. It's used to read files. And then in these parentheses, we'll pass the name of the file. Here we can just refer to the variable that we created that contains the value of essay.txt. Immediately I'm getting this error, right? Let's hover over it and see what it says. File not found exception. So our IntelliJ IDE is smart enough to know that if we tell it to read some file at this location, there's the potential that that file might not exist, right? Or it might be corrupted, or there might be permissions preventing us from reading it. All kinds of things could go wrong that prevent us from accessing that file, right? So we need to throw this inside of a try catch and handle this potential exception for file not found. So let's do that. We'll create a try and we'll throw this inside of it. And we'll add a catch that specifically looks for that exception. File not found exception, FNE. By the way, a common naming convention for your variable here is an acronym for the exception that you're trying to catch. And here we'll just have a print line that says couldn't find the file. Okay, so now we have our buffered reader looking for a file with the name essay.txt. Let's have it start reading that file. We can do that by assigning a string, we'll call this current line, and the value of this will be br.readline. Readline is the method to tell the buffered reader to read the next line of our input. The way this is going to work is the buffered reader will go through our .txt file line by line, and we want it to continue reading until it gets to the end. Buffered reader doesn't actually know from the start how long this file is. All it will do is read this line by line, and we want it to continue reading until the line is null, right? In other words, it gets to the end, tries to go to a next value, but there is no next value, so it's going to be null, right? So next, we'll have a while loop that will continue as long as it's the case that current line is not equal to null. And I'm getting this other error here. Let's hover over this. So it says unhandled exception, IO exception. IO is short for input output. So these are exceptions around reading content from another location or outputting content to some location. So let's handle this as well. We'll add the catch clause. So now we get this catch, IO exception, E, which is fine. And let's have this print IO exception occurred. All right, getting back to our while loop, we want this to print the content of current line, and every time it iterates through this, it'll read that line, it'll print that to the console, and then we want to run current line equals br.readline. And br.readline will cause the buffered reader to not just read some line, but also move to the next line. So every time we run this, it'll move to the next line and then read that line. Okay, so now if we run this, this should print out the entire essay, those 7 lines. Cool, so these are the 7 lines of our essay. What happens if we assign a value to file that doesn't exist? So here, let's say we mistyped this. We called this essays.txt. If we run this again, this time we should hit this file not found exception because it will look for essays.txt, which of course doesn't exist. There, so we caught the exception for the file not found exception, and it printed this line saying couldn't find the file. So our application didn't crash because we handled that exception using a try catch. Another thing to point out is that we don't actually have to specify the exact exception here. Let's actually take a look at what this exception class looks like. Public class file not found exception extends IO exception. So the file not found exception actually inherits from the IO exception class. And if we click on this, now we can see that the IO exception class also inherits from a class called exception. In fact, all of the exceptions that can be thrown, they all inherit from the exception class. The reason this is important is because if I come back to our main class, we don't actually have to specify a file not found exception. What happens if we remove this entirely? So again, the exception that was just thrown was the file not found exception. Let's run this now and see what happens. IO exception occurred. So that's interesting, right? So the try block of code was attempted, but it ran into that file not found exception. But we're not specifying file not found exception in this catch. We're actually specifying IO exception. But this still worked because the file not found exception inherits from the IO exception class. So we don't necessarily have to specify the exact exception that we're going to get. We could actually specify any parent class exception. In fact, we could even say exception here. Exception E, and then we'll say some exception occurred. Let's try this out. So this still worked. We're still handling that exception by specifying exception and then just printing out some exception occurred. Now, this works, but this is actually not good practice for a couple of reasons. A major reason is that by having just a vague exception like this, we can't be precise in our wording and we can't be precise in how we're handling the exception. All we know here is that something went wrong, but we don't know what it is. So the more specific we are, for example, not file not found exception, the fact that we know that this is the exact thing that went wrong, we can give some feedback around uh, us not being able to find a file, and we can handle that however we want. Maybe we can have some other default file that we look for instead, right? Okay, I changed my code back to what it was. Let's go over one more aspect of error handling or exception handling. Let's comment out all of this code and oops, let's talk about something called a try catch finally. So we'll have a try block that will have an integer, int num equals integer dot parse int and a string of 1. If you're not familiar with this, basically we're taking a string that potentially contains some integer value or some number, and then we're trying to convert that into an integer and then assign that to a variable num. And we'll just print out num at the end for some reason. Okay, next we'll have a catch. So potentially, if this doesn't work, um, here we'll throw, so if it doesn't work, you'll get a number format exception. So here, let's say number format exception, NFE. And here we'll say to a print line for could not convert the string into an integer, right? So for example, if we try to convert carrots into an integer, this won't work, obviously, right? So let's run this just so we can see that exception being thrown. Could not convert the string into an integer. And then let's change it back to finally, or let's change it back to 1 for now. And let's add one more clause here called finally. So the way this will work, and let's have some print line that says this will always print. So here's how the finally works. In a try catch, as we've covered, whatever we have in the try block of code will attempt to be run. And if some exception is thrown, if we have a catch that catches that exception, this whatever we have in that block will be run, right? A finally will run no matter what, right? So even if the try worked and the catch block doesn't do anything, the finally will still run. So for example, here's my attempt to parse the string of 1 into an integer, which should work. And then we have our catch, which won't do anything because this isn't going to hit a number format exception. But our finally will be run no matter what. Let's run this task and see what happens. So we get this print line for 1, and then our finally will still print, this will print, right? On the other hand, if we change this to something that cannot be converted into an integer, orange, our catch gets run because this number format exception was thrown, but our finally still gets run, right? So whatever we have in this finally is going to be run no matter what. So when is this useful? You'll commonly see this in scenarios where you have an application contacting either a server or a database. So when you're contacting a server or a database, you need to open a connection to that resource. And then once you're done working with that resource, you need to close that connection, right? So usually in a finally, this is where you'll see that connection being closed. Okay, so we covered quite a bit in this lesson. We covered we covered what exceptions are. We covered how to handle exceptions using a try catch. We covered finally. We also threw in a nice bonus of using the buffered reader and a file reader to actually grab content from another file using a while loop, and handling file not found exceptions or IO exceptions. That's it for this video. If you enjoyed this video, please click the like button. And if you want to keep up to date with all of our videos on Java and all of our other technologies that we will be covering, please click the subscribe button. And if you're interested in signing up for our boot camps, make sure you check out athmatechacademy.com, which is going to be in the description below. I'll see you guys in the next video.